let's take a look at the solution to the question behind me, where we're asked to find x, a missing side length of a right triangle. So in all these cases, we could use ideas about congruencies and similar triangles to special right triangles, the 45-45-90 triangle and the 30-60-90 triangle. However, I'm going to choose to use trigonometry to solve these problems as we're studying trigonometry. So what will we do in part A to find x? Well, we consider the quantities which we know and how they're related. So if we have this included angle 45 degrees, we can see we know the hypotenuse of this right triangle, and we'd like to find the adjacent side to 45 degrees, or the length of that adjacent side. Note that we know a trigonometric function that relates the adjacent side, the hypotenuse, and the included angle of a right triangle. And that function is the cosine of theta. That again would relate our adjacent side and our hypotenuse, the ratio of those two being equal to the cosine of theta. We'll see that we can then solve for x in this case, where we plug in values here. The cosine of 45 degrees equals our adjacent side x over the hypotenuse 2 root 2. And we can evaluate for x. X equals 2 root 2 times the cosine of 45 degrees. Consider the cosine of 45 degrees is just root 2 over 2. So we can find our value for x, where we have, say, 2 divided by 2 is 1, root 2 times root 2 is root 2 squared, or just 2. We find our solution, x is equal to 2. Let's go look in part B now. By a similar approach, what we'll do here is we'll identify the quantities, how they're related, and pick a trigonometric function to help to relate those quantities. So here we have some included angle 60 degrees, and we know the adjacent side to 60 degrees, and we'd like to know the opposite side. We know a trigonometric function that relates those quantities. It is the tangent, which relates the opposite side and the adjacent side by ratio being equal to the tangent of that included angle. Filling in values, we have the tangent of 60 degrees is equal to our opposite side x over our adjacent side 2. We find x equals 2 times the tangent of 60 degrees, or x equals 2, the tangent of 60 degrees. We know the terminal point corresponding to 60 degrees would be 1/2 comma root 3 over 2. So the tangent of 60 degrees would be root 3 over 2 divided by 1/2, or just root 3. Here we have a solution for x. It's 2 times root 3, or 2 root 3. And finally, we look at C, where we have the included angle 30 degrees. We would like to know the hypotenuse, and we know the adjacent side. To relate the opposite and adjacent side, use the sine function. The sine of theta is equal to opposite over the hypotenuse. In this case, we have the sine of 30 degrees is equal to 8 divided by our hypotenuse x. See, by rearranging, by multiplying x on both sides and dividing by sine on both sides, we find x equals 8 divided by the sine of 30 degrees. Noting the sine of 30 degrees is just 1/2, we have x equals 8 divided by 1/2, or x equals 8 times 2, or 16. And that concludes our problem.